we have with us Dr. Sonali Bhowmick. She is working as an assistant professor in Department of Civil Engineering, NIT-Rourkela. She did her BTech in Civil Engineering from NIT Agartala and post-graduation MTech in Earthquake Engineering from NIT Silchar. After that, she finished her PhD in Structural Engineering at IIT Roorkee. She worked for a short period as a postdoctoral researcher at IISc Bangalore. Then she joined NIT Rourkela and she has more than 3 years teaching experience. Her research areas are in fracture mechanics of engineering materials and structures, fatigue analysis of concrete, theoretical modeling of crack propagation, digital image correlation, and acoustic emission analysis. She has 10 publications in high impact journals and in reputed conferences. She is currently guiding 2 PhD students. She has guided 5 MTech thesis projects. She in the as a service to the department, she is a professor in charge of weak students of the civil engineering department. So I, I invite Sonali madam to deliver the lecture.
Thank you, Professor Gitu, for the introduction and also giving me the opportunity to speak on this topic. And also a very good afternoon to all participants. So I'm starting with my presentation, which is I'm going to talk about fatigue fracture behavior of quasi-brittle material.
Excuse me. Excuse me, madam.
Yes.
You can go in full screen mode if you are comfortable.
Full screen, right? In this MS Team, isn't it?
I think slideshow. I think it will work. I think.
Okay, the slide. Yes. Actually, my internet is a bit slow. That's why. Okay.
Yeah, we are able to see that.
Now you can see that. Okay. So, so I'm starting with the very basic of a quasi-brittle properties of quasi-brittle material. Quasi-brittle materials are nothing but we are dealing with concrete. So here I'm talking about the behavior of concrete and what will be the crack propagation and crack growth rate and what will be the fracture behavior of concrete under the action of both static and fatigue type of loading. So what is the necessity actually? I should start with first that what is the necessity of studying or maybe doing research in this area. So I'm just briefly explaining what is the internal mechanism of concrete. So as we all know that concrete is a heterogeneous material. So definitely it will be full of micro crack and or we can say that pre-existing cracks available within the concrete. So in that case, we can't exactly expect that the material property, which it should not be similar to the properties which are other material like alloy and metallic structures are having. So due to this property, heterogeneity of concrete is having, we are considering that concrete is having pre-existing flaws and under the action of any kind of load, these flaws will finally have some different behavior than the metallic structure. So what could be the different behavior that I will discuss here. In this PPT, if you can see, a plot is given which is nothing but, I don't know, there is no arrow. If you can see the arrow, my cursor, through my cursor. So I'm just talking about this fracture process zone image where a micro crack is depicted, followed by a fracture process zone, and then you have true crack.
Madam, excuse me, madam.
Yes.
Can I just, if you want to show the cursor, probably there is a pen kind of thing, right? There is this.
Okay.
Besides this, and that laser pointer you can use, I think. You can go to that pen,
Yeah,
click on it.
I think this is working fine. Okay. So this true crack, if you can see here, there is a fracture process zone, and again you have micro crack, and this is your crack opening displacement. So what exactly this picture is depicting? Here it is the internal behavior, internal modeling of a concrete, where we are expecting that if this is the crack, ahead of this crack, if you can see that if this is the crack, these are the edge of crack, ahead of crack there will be very tiny cracks, which we can call micro cracks. So these are bunch of micro cracks surrounded by the vicinity of this crack, and this is exactly the true crack, which is pre-existing crack. So in that case, what will happen? So due to this nature and good quasi-brittle nature of concrete, what we can expect here? If you can see the plot here, FT and FY, and elongation, here in this plot, it is clearly depicting that what is the a zone, which is nothing but here, which is nothing but this zone I am talking about. This is post-peak zone, and this is the softening zone, we can call it, and this zone is nothing but where the strain localization occurs. So this strain localization is nothing but when you have a pre-existing crack, which is definitely it is there in concrete, under the action of any kind of load, maybe fatigue or static, those cracks will try to propagate. And then when you have too many microcracks surrounded with this crack, those microcracks with merge with each other and accumulate with each other, and finally uh, it will make a bigger crack, and as we know, then final failure will occur. So this strain localization phenomena, which is only occurring in quasi-brittle material like concrete, not in metallic structure. So the crack pattern and the failure pattern, which is much more complicated in concrete than other materials. So this is the reason the fracture mechanics theory, which is very much important, because there are Sir, can you hear me? Hello, am I audible? Hello, am I audible?
Yeah, madam, you are audible. We just lost the network connection for short while. I think. I also, I think, same issue happened for me.
Okay. So, before peak load, these things are happening due to the non-linearity before the peak load. Now, what is exactly the non-linear fracture mechanics? It is nothing but these models. If you can say that in that image, if you can see that there is a crack initiation, and there is an opening, WGWC. This theory depicting that how much stress is generating, what is the severity of stress ahead of crack tip, and we actually call it stress intensity factor also in those models. And these stress intensity factors define the severity of crack ahead of crack tip. So I'm not going deep into this this analytical thing here, but this fracture energy that I want to talk about, which is nothing but energy required to propagate a crack, or you can say that create a new surface. So this energy is something which is very much important to compute or to understand, to know the fracture behavior of material like concrete. So in this kind of model, the energy, which is, as I mentioned here, fracture energy, which is a very vital parameter through which we can understand that what will be the rate of crack, or maybe what will be the behavior of crack propagation, or what will be the pattern of crack. So based on this, there are many models developed that subsequently I'll be discussing about it. So if I'm talking about non-linearity, and due to this complex phenomena of concrete, when it is subjected to static loading, monotonic loading, which is not repetitive in nature, still it is easier to compute the fracture pattern and fracture behavior of concrete, but it complicated when we are talking about fatigue of concrete. Fatigue means you have a structure which is subjected to the repetitive type of loading for a longer period of time. So what is happening in fatigue? In that introduction flow chart, if you can see that here, it is mentioned that applied stress is well below the yield limit of material. That means the stress value in fatigue loading, the stress amplitude will be very low, maybe lower than the yield limit, but it is subjected to longer period of time. Suppose if you have a structure and if it has a service life of 50-60, if you can expect that this load is applied with a small amplitude, but it is applied a longer period of time and in repetitive cycle. Now in fatigue, if you can say that to extend the service life, fatigue life assessment in terms of applied load cycles is important. Why it is important? Now we want to know what will be the fatigue life, what will be the life of a structure. But in case of other materials which is well defined, that well-defined theories are there, models are there, which can directly tell you what will be the fatigue life of a structure. But in concrete, which is very less explored now, people are working a lot in this area, where you can predict the structure's life, or maybe fatigue life of a structure, by considering all important aspects, all important phenomena, loading patterns, and all parameters related to loads, frequency, and amplitude, and you have other factors like environmental factor and your concrete properties, everything. So this is an important thing to learn and to understand what will be the fatigue life of a structure. And why it is also important, because this fatigue is nothing but this is a microstructural change within the concrete, and which is gradual and which is permanent also. So which is not visible in that eye, definitely it is happening internally. As I mentioned that we can correlate with the structural mechanism of quasi-brittle material like concrete. Just now I have explained, where you have so many micro cracks, and then this sample is, or maybe this structure is under the action of fatigue load, which is nothing but maybe it is amplitude is low, but it is applied for a longer period of time. So in that scenario, we can expect that there will be progressive damage, and if we don't predict the damage, quantify the damage, we don't know when the object will fail. And in that scenario, it already happened many times. There are many examples that if you can Google it, if you can get to know that there are many examples that an object designed for a particular life service life, but it has failed without any alarm before time. So these are the very crucial phenomena basically for structures subjected to fatigue kind of loading, repetitive kind of loading, and for the structure which are heterogeneous in nature. So these are the process, actually gradual permanent process, and due to which there will be strength and stiffness degradation, and due to increasing the load, definitely when it edges the number of cycles means the repetitive loading intensity will increase, and then those pre-existing flaws, just now I have mentioned what from these pre-existing flaws the crack will get initiated, or maybe the existing micro cracks will accumulate, and finally a major crack will develop and this catastrophic failure will occur. So these are the things are happening when a concrete structure is subjected to fatigue kind of loading. One thing here we should understand, I'm talking about here only plain concrete, reinforcement is not embedded in it. Now in this specific area, this area is still again a vast area to understand where what will be the behavior of reinforced concrete under fatigue loading, which I am also working here. But here I'm starting with the basic with plain concrete. So what exactly fatigue loading? There are different types of fatigue loading: low cycle fatigue, high cycle fatigue. Low cycle fatigues you can consider structures subject to earthquake. With this timeline, with these values, you can understand with number of cycles that what is the intensity and what is the upper and lower band of cycles for high cycle fatigue loading, super high cycle fatigue loading, low cycle fatigue loading. Basically, we are dealing with most of the cases high cycle fatigue loading, all with maybe the amplitude will be very low. So how to handle those fatigue type of problems? So as I mentioned that metallic structures or in the area of metallic structures like steel or other alloys in the field of aerospace engineering. So people are working in this area extensively, and this ascent curves is a one approach through which one can find out the fatigue life, and this is well established. But this ascent curve is not applicable, not fully valid for structures like concrete. I'm not going deep into the ascent curves because I'm here, the things I'm specified are limited to concrete. So for concrete, there are many other approach, fatigue crack propagation approach, through which fracture mechanics based fatigue crack propagation approach through which one can predict the fatigue life. So this ascent curve approach, while it is not valid for concrete structure, because it is not fully exclude the concrete failure mechanism, also does not differentiate crack initiation and propagation phase. Because since concrete it is a bit complicated than alloy, because in concrete there is a presence of fracture process zone, just as I have explained, which is non-linear in nature. So it can accurately predict the address the problem. It involves extensive experimental data collection and does not involve fundamental material parameters which are not valid here. So what are those fatigue crack propagation approach does? So here we assume that the structure has pre-existing crack of some initial size. So in that approach, because this approach is based on that, we assume that there is a pre-existing flaw or maybe a crack of initial size. Crack propagation, and then when you assume this, you can find out the critical crack length, and what will be the number of cycles, all those things based on this assumption. And you can understand that the failure is prevented even without giving enough safety. So what is that actually? These are the things, few things we want to explore here. Yes. It is much. Is this this side of PPT here? It is visible. Is it visible, sir?
Yes.
Right side.
It is visible.
Right side, sir.
Right side. We are just seeing the slide fatigue crack propagation approach, and then there are.
For me, right side is not visible. I don't know why. It's left location. Okay. So I'm just yeah, I'm just talking about fatigue crack.
I think you can escape. You can press the escape button, and then I can start.
No, I don't. It's not issue for me. I can carry. For other sides, just to make sure. Yeah. So
Actually, we
so
lost the slides now.
I mean, last slide.
We lost. Means we are, I'm not able to see the slides. I don't know about other people.
Can you see the
Yes,
slide?
sir. I'm also not see the slide.
Yeah, I think some.
I couldn't see
Probably
the slide.
reshare the presentation.
Again, I'm sharing presentation. I don't know what is this. Got hanged. Is it fine now, sir?
Yeah.
Yeah. Okay. Okay. So on that note, to predict the fatigue crack growth of concrete, there are many analytical models till now developed based on the some pre-existing empirical formulae, and also many models that predict the fatigue crack propagation of uh, concrete. Here I am just giving some overview. This is the conventional crack growth law, which is called Berry's law, which is specifically developed for metallic structure. You can see here DADN C del K to the power n. DADN is nothing but our crack growth rate, stress intensity factor, and these are two constants. So this is the conventional crack growth law. Based on this, one can find out the crack growth rate. Now here, what is the issue? It has been now, there are many research going on in this area. Why this specific equation is not valid for concrete? Because concrete is dealing with much more parameters, and finally researchers come out with many parameters. Like in this PPT, if you can see the evolution of Paris law prediction for crack growth rate in concrete. It started with 1963, and now the latest one in 2019, it has been derived, which is crack growth rate law, which is derived for concrete, plain concrete. If you can see the last expression is dealing with much more parameters like critical energy, energy release rate, crack length, and you have other parameters like stress ratio. You have other parameters like energy release rate, sigma t means tensile strength, many more things. So these are some development in this area where it was the attempt to develop a fatigue crack propagation model which can accurately predict the fatigue crack growth rate, finally the fatigue life of a structure. So these models, when understanding this model, it has been understood that every model was refined, every model has been improved eventually, and finally arrived with a model which is much more improved and robust, and which is giving a very good prediction of fatigue crack growth rate. So this is the last model. This analytical part is up to this much, where already people have done. In this model already here it has been proved, and this is the, in this paper already things are explained clearly or in more detail, but here I'm just mentioning few things that in analytical area, when I'm talking about how to predict the fatigue crack propagation model, it depends upon multiple numbers of parameters, and it is very important to verify those parameters, validate those parameters, and to understand whether this parameter has direct and indirect effect on fatigue crack propagation model or not. This is a very rigorous study with each and every parameter, and that finally you come out with a very robust model that can give you a fatigue crack refined or maybe a modified and robust model of fatigue crack propagation rate and fatigue life of a structure. So this is up to analytical, where people are already explored. Now here there are few things. This type of model only limited to plain concretes, where there is no embedded reinforcement. Now, when you are talking about reinforcement, there are many more things will come to the point, because it becomes that strain difference between reinforcement, concrete, bond force, corrosion, everything will come in that scenario. So, what are the future aspects for analytical area to predict the fatigue crack growth of concrete is nothing but to explore to develop a very uh, improved model which can clearly predict the fatigue crack growth rate of reinforced concrete. But here the critical areas that just now I have mentioned, corrosion, environmental aspects, durability, all those things need to be considered. So here are some challenging tasks which people have started to doing. So I am hopeful that we will come out with some good observations and informations. Now this is one aspect. Now, as we already understood that I have time, right, sir, Professor Getty? So now we already have understood that.
10 more minutes, so we can.
10 more minutes, okay. I'll quickly just give the description of what is happening in experimentally, or maybe what are the advanced crack detection techniques. These are few things I just want to explain here. There are many more things, basics. I'm sure all of you are in that field. All of you are aware of this. But here, where I'm working in the area where the advanced crack detection techniques, which is non-contact techniques, DIC and acoustic emission. Here I'm explaining few things of DIC, where this is nothing but non-destructive. This is an image processing technique where we compare images, we click images of during the experimentation, and we compare both the image means deformed image with undeformed image. And by doing this, there are already softwares available, and also there are some open source algorithms available. Those algorithms one can use to and one can refine, one can modify, one can improve to find out the surface strain and surface displacement of materials. So this is a very long process of digital image correlation technique, where it is not only we are dealing with the algorithm, we have to prepare the sample, and also as I mentioned that in that approach, what we do, we are always considering a pre-existing flow or crack size, which is we call here in experimentally notch size we are considering. And for notch, those notched beam, by preparing those samples, by clicking those images of in some particular interval of loads and time, we are getting those images, and the next step is to rigorous analysis of all those images. So this is exactly what is happening undeformed subset and deformed subset. We have these points M, Mn, Mn's line. If you can see that these are undeformed points, and after deformed, how it is displacing. Similarly, this is U displacement, and in V means vertically how it is displacing. So it is nothing but this displacement is capturing through the cross correlation algorithm, and it is capturing the how much it is getting displaced in vertical and horizontal direction. We can get those data in terms of strain and stress values. So these are the sample preparation. I'm just briefly giving, and these are the setup, how a setup set for these steps. I'm not explaining much here, because just to give you an overview of how this experiment is basically done. And This is the DIC procedure using the NIT-Rourkela algorithm. This algorithm already developed for other materials also. Now for concrete, by calibrating this algorithm, we can use for plain concrete. Till now, this algorithm has been modified for plain concrete. We have planned to develop it for other purposes also. Here, these are calibration procedures of this algorithm, where those subsets and these are input parameters, because definitely we are dealing with concrete. We never we don't know what is the accuracy of those results. These are surface displacement, so we can't blindly rely on whatever a algorithm is giving us the data. So in that case, the input data has been verified repeatedly with different input parameters, and we found out with very good results with some optimum values. So this is our close view of painted speckled surface of our sample, where you can see this is AOI, area of interest. This is the zone analyzed through DIC software or DIC algorithm. Now, what is the use? Why those data are used? One is surface displacement strain. We can get it. For other purpose also we can use it, but in fracture analysis we don't only want surface strain and displacement. We want to know what is the fracture patterns, what is the crack growth pattern, like this. So in that case, using those data, two methodologies already developed. One methodology is to find out the fracture process zone size in terms of length. Another methodology is to find out fracture process zone width in size in terms of width. So both the dimension is very important for fracture process zone, because as I mentioned that this fracture process zone is crucial and it is totally related to the fracture behavior of concrete. This nonlinear zone, if someone predict that what is the area, how much area it is means within the concrete, what is the size of this fracture process zone, then one can understand that how much energy structure can absorb or can dissipate accordingly based on what is the problem. So here a method already developed to find out the fracture process zone. Length. So the method says that the data, whatever we have analyzed, those data, extracted data has been used to develop this methodology. In this methodology, if you can see here, in this particular image, here you can see the clip gauge, and you can see the notch tip, and these are Y1, Y2, Y3, and Yn. These are reference line. So what it has, what was the study within this straight line of Y3, Y2, and Yn? What is the displacement? That means what is the horizontal displacement of each particle has been analyzed. So from this data, as I mentioned that in deformed data, this displacement point can be located. So using those data, how much displacement occurred, that has been computed within this methodology. This is a step-by-step procedure. It has been explained here, and also these using those data, each line displacement has been found out, and it has been found out that there is a change in displacement in each line, and also definitely within the crack tip, when we consider the displacement jump will be more, but when we go upward direction, jump will be less, because we have no crack opening here. So these things can be well understood with these plots. These are nothing but jumps. These are near the crack tip, you have an opening, and when you go upward direction, there will be a certain distance where there will be no crack opening. So since there is no jump crack opening, we can understand that this is the point where after that there is no crack growth. And this is the point after that we can understand that up to this there is a development of very numerous number of micro cracks, and due to those micro cracks it happens that its crack got propagated. So these are two plots. This is under fatigue loading, this is under static loading. This study has been carried out. If you can see both the cases, same thing detected, that in the opening in the near the crack tip, the opening identified is a very large, and when you go upward direction there is no gradient. So in this work we have named it differently, that displacement gradients, which is 0 here, which is significant, it has significant jump. Now this analysis gives us this type of plots where the crack propagation you can clearly see that how it is getting propagated. Both the crack plots are one is for fatigue, one is for static loading. These are the image we are getting, and data we can get it from the MATLAB program. Now this is about the fracture process zone length, and now this work can be carried to fracture process zone width, where there are methodologies that is also developed, and it has been verified by fracture process zone length that it is working fine. This methodology working fine. So why it is important to find out the fracture process zone width? Because it gives us the accurate estimation of fracture process zone size. In previously it was understood that there is no significance of finding out the fracture process zone width, but eventually many other researchers also found out that it has significant size, and also it is very much important to find out. So in this scenario, a set of data again analyzed, and these are some plots for DSA analysis. If you can see here, this is for displacement data extracted in V direction. As I mentioned, that deformation in V direction, that is in vertical. So that's how it has been calculated, and finally we arrived with some conclusion that finally the size of fracture process zone can be computed with the help of DSA analysis, and also you can say that non-contact techniques like DSA analysis and other technique like acoustic emission also. This is the acoustic emission also area where I also found out the fracture process zone size and the fracture patterns, where I have not included here, but this is the area also where it can be fully verified with both the non-contact techniques. So here, from this validation, from T, it has been detected that from this contour, whatever this algorithm has given us, this contour is clearly matching with the fracture process zone T, which has been found out using the methodology developed to find out the fracture process zone tip. From this tip directly can be found out the width. So this width already found out, and these are the values here. This is the height and this is the width, 20.585. This is my students' work, so we are working in this area. So after this much, I just want to conclude here. There are many more areas, many interesting areas where using non-contact techniques, other patterns of DIC, patterns of crack propagation, behavior of crack, whether the crack path, all those things can be found out. So here in conclusion, I already mentioned in every slides that what is actually the concluding things here, remarks. So here I just want to conclude that in this area, why it is significant already explained, and why what is the necessity to doing this work, because since concrete is a complex, it has complex behavior, and under the action of repetitive loading, it becomes more complex. So in that case, this approach gives us more accurate values, accurate prediction of life of the concrete structure. So basically, in future, experimental studies using acoustic emission, DIC, SAM can be used to understand the failure mechanism of concrete under fatigue loading. And finally, those analytical tools can be developed to damage assessment in concrete structure. Different theories like thermodynamics theory, peridynamics theories quantify the damage and design rehabilitation schemes. So I'm just completing my talk here. Thank you everyone for your patience.
Thank you, Sonali madam, for your excellent presentation. We ask audience to, if you have any queries, you can ask madam.
Yeah, sure.
Ipsita madam, if you have any question, you can ask about the fatigue in concrete or DIC, digital image correlation, like that. We have a guest from CBRI. We have Mohanlal, CBRI. He is working at Central Building Research Institute. So, sir, if you have any question, you can ask madam.
Hello?
Dr. Pandit, sir, if you are.
Hello?
Yeah.
Yeah, can I ask a question, sir?
Yes, you can. Ipsita madam, you can ask.
Yeah, ma'am, please.
Yeah, Sonali ma'am, I saw the law, Paris law that you said, which has gone through many changes.
Hello. Ma'am, your voice is not clear actually.
Hello?
Hello. Ma'am, your voice is breaking actually.
Am I audible to you?
Yeah, little bit audible, but maybe it's not that loud.
Yeah. I can't check.
You can repeat. You can ask the question. I will repeat it to madam.
Okay. Sir, ma'am, there's a Paris law, and the Paris law has gone through different evolutions, like different years. Many parameters were added to that formula, the calculation that was developed. So, what were the parameters included in the formula that you revised in the year 2019?
Yes. So actually, what are the parameters used? There are many arguments, as I mentioned that. There are many parameters. It has directly, indirect effect in static crack growth phenomena. Among these, the parameter related to energy, that means they're nothing but the function of load. So these parameters are much crucial. And to understand those parameters, this kind of work, basically the last equation, if you can see here, their energy release rate, critical energy, all those things has been computed. These are nothing but energy computed for upper or lower load levels, load amplitudes. So these things gives us a clear information of crack growth rate, whether for different stress ratio. So it is important to understand the energy or calculate the energy in this kind of models. So for my understanding, whatever I have developed here, so here these main parameter here is energy parameters, and following by energy parameters, there are other parameters also like crack growth, crack length. Dimension is a vital parameter also, because we know that in fracture mechanics, but basically for concrete, the size effect is also very vital things. So the size of the structures also has importance. So in this particular paper, if you can go through, there is a statistical analysis through which one can understand that which parameter has much more effect in fatigue crack growth phenomena. So it is a very long procedure, and also, as I mentioned, that those parameters when you choose, you have to very much means with much caution you have to choose, because we need to understand that what exactly one parameter has effect in particularly individually in one in this particular phenomena, and altogether how it will be behaving. So these are few things.
So
Okay, ma'am.
I hope the question was answered, Sita madam. And I think we are short of time now. So let's thank Sonali madam again for her talk.
Thank you,
And
sir.
we hope we can continue this kind of talks in future also. So our next speaker, thank you, madam.
Thank you, sir. Thank you for